Our next speaker is Dr. Wayne Delker. Wayne has spent more than 30 years in business, leading innovative organizations and developing innovative processes, capability, and culture. He recently retired as Senior Vice President and Chief Innovation Officer of Clorox, where he led worldwide R&D and innovation for all of the company's products, processes, and packages. We're thrilled that he's now a member of the Fung Institute staff, leading the Capstone project program with responsibility for all of the year-long projects that give our Berkeley MN students the opportunity to combine their technical knowledge with skills in teamwork, leadership, and innovation to develop new products and technology. So welcome, Wayne.
Thank you very much, Beth. Let's go over that. It is a pleasure to be here. Good morning, everyone. Been much better. Several speakers have talked about the importance of you engaging and speaking up. I want to try that again. Good morning, guys. Good morning. That's better. As you will undoubtedly see, and based on Beth's intro, I'm a little different from most of the folks you'll talk to today, okay? Most of the people are professors, educators, have committed, have really given their lives to Berkeley and making it the university that it is. I've been here 6 months. My career of 35 years was split between the first half at General Electric, leading large R&D, innovation, and engineering groups, and then the second half, as Beth said, being Chief Innovation Officer at Clorox, where again led a lot of new product development. And one of the things that when I retired, I got to tell you, I had absolutely no idea that I would do something like this. Okay, kind of figured I'd go off and enjoy myself. 35 years, successful career, have fun, have grandchildren, play with them, maybe do some gardening, some cycling. Sounded pretty good, actually. Didn't work out that way, and it didn't work out because of this. This mission that Lee talked about is a beautiful thing. And for me, it's very personal. Over my career, I've probably had well over 1,000, maybe 2,000 actually, as I think of it, engineers in my organizations, engineers and scientists. This applies to scientists as well, in my organization. And I've observed some things. That engineers that are able to do this, which is to transform themselves into leaders and innovators, have very successful careers. And engineers and some of the brightest people that I've known can't do that. They view themselves as just a technical expert. Now, there's nothing wrong with that. Companies need technical expertise. But I'd watch these people get sidelined. I saw their career kind of pushed over to, you're the expert in this, and when we need that, we'll come to get you. And they were frustrated. They didn't have the kind of career that they could have brought and the value they could have brought, and the company lost all that potential. So I became very passionate about what can we do to build on your engineering background to actually turn you into leaders, which will ultimately make you more successful and your companies more successful. Recently, however, I've got a second reason why I'm really into this, and that is if you look around the world, we have lots and lots of challenges. Whether it's water, having sufficient water for everyone on the planet, whether it's energy, climate change, global pandemics. The World Health Organization says it's not if we're going to have a global pandemic, it's when it's going to happen. Poverty, terrorism, now cyber terrorism, and then as Coleman just talked, this idea that work is changing. The fundamental way in which people bring value is changing because of artificial intelligence and robotics. There are a lot of challenges ahead of the world, and the solutions to those are technical. And our organizations absolutely need people leading them, not that are just good in business, but really also understand the technology. And you guys do that. So for me, the reason I am here, it's not for a job. It's not for my colleagues, although I love working with them. It's not because I have any expectation. I'm building a giant career here. It is you. I truly believe that engineering leadership and turning folks in engineers into leaders is the single most important thing we as a country, a society, and a world need to do. These are some pictures from this year's class. They're doing some fun things here with their projects, their Capstone projects. But it really can make an incredible difference. I want to show a couple more slides before I jump into talking about the Capstone, because I know you're all very interested in it. Now, these slides are from before I joined Fung. This is from a presentation I gave while I was a Chief Innovation Officer. And it kind of talks about what is the engineer of the future going to look like. And you've heard some of these themes, but I just wanted to give it to you from my perspective, because these slides are from my past, or maybe from your future, because this is where you're going. I like this picture because it's all about balance. Okay, what we're talking about here in this program is creating balance in you as engineers and leaders. And at the top of that is technical excellence. You can never give that up. When you graduate and leave to get a job, you're going to be expected to be an excellent engineer. And fortunately, you're in one of the best places in the world to really continue to develop your skills there. But you also have to build on that in terms of leadership and teamwork. Teamwork, because everything you do once you leave here will be done as teams. There are virtually no jobs anymore which are individuals. You need to work on a team. You need to be successful in teams. And then leadership. And I use this word very, very broadly. Not just leading people, which is what people often think of, but thought leadership. One of the most successful businesses in Clorox, it's a business that is disinfecting hospitals, and we think has probably saved on the order of 50 to 60,000 human lives a year, was created by an engineer without the authority to create a program, because he saw the opportunity. He saw a need. He saw the technology, the disinfecting technology that Clorox had, and he convinced the company to build a business. It's worth about $350, $400 million now in annual sales, and is saving human lives. That is leadership, just as much as someone who leads a group. And it's the kinds of things that you need to learn how to do, and you'll learn here. Third is innovation and entrepreneurship. Once again, you're in the best place, and one of the best places in the world to learn this. But as the world changes faster and faster, it's the innovators that are going to win, and the people that have that entrepreneurial way of thinking and actually are comfortable with change. In fact, they're not only comfortable with change, they love change. They like driving change. So it's bringing those together, but also, as Coleman and Lee and Phil talked about, it's knowing in business how they work, being able to read a balance sheet. That's actually really easy, by the way. And really understanding, more importantly, the different perspectives of folks. Because when you go out into your business assignment, you're no longer going to be working with just technology people. You're going to be working with marketing people, okay? They have a very different background, very different experience. Salespeople, manufacturing people, a whole range of folks. And you need to know how all of those pieces fit together. That's one of the things you learn in this program. And then the most important thing is a passion to create value. Value for yourselves, for your family, and also for the company and the teams that you're around. So it's really kind of pulling all of these together that I think we're going to help you get to advance on. Now, some of you are sitting out there saying, hey, I do these things. I know these things. And I think you do, because you're some of the best, or you wouldn't be sitting in this room. Our intent is to make you better in terms of how you can build as a leader. Now, as you can imagine, taking my vision of what the engineer of the 21st century looks like and looking at this gear slide, which I absolutely love, you can see the marriage is virtually perfect, okay? You have at the bottom your technical expertise. You're going to continue building that at one of the strongest engineering schools in the world. At the top, you have your leadership business knowledge that you're going to gain in a classroom phenomena, working with folks like Alex, who is great, by the way. He does a sensational job, and the students love him. And then there's this little thing that I've got in the center that I kind of direct called Capstone. And I think, as several speakers have told you already, the real value of Capstone is it allows you to bring your technical education, your leadership business education together in a very practical way and practice the kinds of things that you're going to be doing once you leave here. Now I want to start talking about the educational goals and how we think about Capstone. First, and this is really important, and Coleman mentioned on this, these are not made-up projects, okay? You are learning by doing on real problems, real projects that create value for the university and the world, Okay, so we're not creating little projects, and sometimes in your undergraduate courses, there'd be a little project to illustrate a certain thing. That's not what this is. These are real, and that has its challenges, but also incredible satisfaction when you do it. Second, you are in, again, a very advanced technology universe here at Berkeley and the Bay Area in general. So that the capstone projects that you're going to be seeing are technically challenging. I won't mince words, okay? They're pretty sophisticated, but you're up to it. And you learn leadership. And then most importantly, I think, going back, is this teaming experience. Now, there are 3 principles that we really use for Capstone. Now, as Coleman indicated, there are a lot of different types of capstone projects. In fact, there's 83 of them this year. And you might actually argue that almost every one's different, okay, depending on their circumstances. But no matter how they're organized and what they do, they all try to meet and to succeed in meeting these 3 principles. First, you will learn by experimenting, failing, recovering, and then succeeding. We want you to fail. That may sound weird coming from me up here because your entire career you've probably been told that failing is really bad, okay? In the real world, you have to learn how to fail because if you don't learn how to fail, you don't learn how to try. And you have to go through that experience of trying something, realizing it's incredibly challenging, trying to get it done, falling flat on your face, but then knowing that you can pick yourself up, recover, and keep on going. So many people that have, and it's a really acute problem in scientists and engineers, that have tremendous ability to be innovators are constrained by the fact that they're afraid to try and fail. So in the capstone, we are going to force you into that. You're going to find they're intense, okay? They're complicated, they're challenging, but it's okay, because at the end of the year, you're going to come out in a very good place. Second, we want you to generate new knowledge. And I contrast this with a lot of the courses you've probably had so far as an undergraduate, where what the course is really trying to do is increase your mastery of existing knowledge. When you leave here and go out and work with a company or start your own company, no one cares about the mastery of existing knowledge. You're not getting paid for that. You got to have it, but you're not getting paid for it. You're getting paid for creating new things. So in the capstone, we want you to have the experience of not only doing something that's known, but extending it, doing something that's totally different. We'll talk a little bit about that later. Third, we need you to experience what it's like to be on a team. People have this very romantic vision of what teams are like, and they're all kind of fluffy and nice. Well, in reality, they're not, okay? Virtually every team I've ever worked with, and I've probably worked with hundreds, go through this sequence of events. They form, come together as a team around a problem, real exciting, everybody's excited. There's a little bit of a honeymoon period as you all get to know each other. And then they start storming because you find out there's interpersonal problems. When you want to do something and you want to do something else, and by God, you're going to fight it out, right? That happens. It always happens. And that's what you're going to have to deal with, because then you're going to have to figure out as a team, how do you normalize? How do you as a team figure out how you're going to take all of those differences that you have as individuals and bring them together into a focused team event, and then leads you to high performance. That's when you perform. Teams that go through this process come out of it. They're a little battered sometimes, I'll be honest, but they come out of it as a high-performing team, high-performing organization, and they're able to do anything. When you get a team to this level, there's no challenge that's too high for them, too great for them. They can succeed and do some unbelievable things. We want you to go through that entire process. And the second, innovation. We talked about the importance of innovation. In your capstone, we're simulating kind of what the total innovation process works like. Now, many of you, maybe most of you, are sitting out there thinking that innovation starts with technology. It doesn't. Most engineers do feel that it's technology-driven. I'm going to create this giant, great technology, and then it's going to save the world. In general, that doesn't work. And what does work is really understanding the need. What does the world need you to do so that instead of trying to push your technology, You're now getting it pulled, okay? And that means understanding your customers, what their needs are, their experience. You kind of got to get out of your technical world and jump into the world of your user in terms of what is it that they're going to do. Getting feedback and understanding the broad impact of your world. Then comes the technology, and you'll have access here to some of the best technology around, okay? That allows you to start developing products and prototypes, doing evaluations and demos, and then the magic happens in the middle, which is creating a solution, which is just really marrying the need that you've seen, that your customer has, with the technology that you're an expert of, that you have access to, and that you can understand because you're an engineer. And it's bringing those two together. And this is where you get into designing, prototyping, testing things with consumers, doing tests, and it's a lot of fun. And we'd like to, in the Capstone, have you feel this entire process. Now, the reality is some of your projects will focus in one of these silos, okay, versus the other. But even then, you'll have a view to the entire process. So this is kind of how you get to feel innovation. Now I want to jump into, first actually a bottle of water. I want to jump into kind of the types of capstones that we have that Coleman was talking about. Because I know this is something I could gather from all the questions I got last night, which was actually a lot of fun, by the way, that is top of your mind. First, on the left-hand side, everything you see up here, we'll talk about teams. Okay, remember, this is all about teams. And the first type of capstone we have, and this is actually new this year, so you won't see a lot of it on our website, is what we call the Capstone Experience Class. And 4 departments are experimenting with this. EECS, Nuclear Engineering, IEOR, and Mechanical Engineering. What this format starts in the fall with essentially teaching you some of the foundational tools that you'll need not only to be successful in your capstone, but also what you're going to need after you graduate and go into your companies as one of these engineers. So it kind of takes and brings everybody along to equip you with the skills that you need. Then a little bit of preparation for the capstone in the fall, but not a lot of actual capstone work. But then in the spring, you get into a very intense one-semester capstone, which meets all those same principles, gives you all the same experiences, and allows you to essentially accomplish the objective of your innovation. These projects generally are using Berkeley technology. So these are the technologies that you'd be using in a project like this are coming from the faculty. And the faculty is putting a lot of focus right now in terms of building the front-end courses that make sure that you have the learning that you need to be successful in the capstone. And then they'll be leading those capstone projects in the spring. So there's that format. The second, let's go a little deeper on that. Because we've created 7 of these, and you'll have a lot more opportunity to talk about these in the breakout sessions, because I'm going to go pretty fast here, so I don't want you to feel too concerned about it, or we'll have some time at the end for Q&A. Basically, EECS has 2 of these experience sessions that they're doing. One is augmented reality and virtual reality, with Professor Alan Yang, who was here and will probably be back, so you can talk to him. The fall, you can see the kinds of things you're learning around graphics, computer interfacing. And then your spring capstone will break into multiple teams, each faculty-led, with industry sponsors in those teams. And here, it's really a very entrepreneurial type of project as you're trying to take what you've learned in VR, AR, and really start to apply it to real-world problems. The second experience class they're developing is the Internet of Things. This one's really kind of interesting, where the class will actually, in this fall, you'll do design training, learn design, either analog or digital. And then the class in the spring will divide into different capstone projects, doing different subsystems of building an actual wireless device. The thing I really like about the approach they're taking here is just as if you were working at Apple on an iPhone, you're going to be focusing on one component, but you have to interface with all the other components because your output is somebody else's input and vice versa. So this class will give you that opportunity to do that interaction. Again, there's some very good details on the EECS website if you're interested in it, if you're an EECS student. In industrial engineering and operations research, really 2 major experience courses I've shown at the top. Professor Fleming, who you just heard, is really leading both. The first is around autonomous driving strategy. This is a joint program with Volvo and actually the University of Gothenburg in Sweden. It's the first time I think we've ever done this, of bringing two universities together. They have a similar program as this. And working here at Berkeley, because Volvo has established a new center down in Silicon Valley on autonomous driving, but not just the technical elements of autonomous driving. The question here is, with all of this immense amount of data we have, how do you take that data and pull insights out of it to better inform strategy? So this is going to be a lot around how do you visualize data? How do you actually manage it ultimately so that Volvo, who finds themselves in a rapidly changing market, can make better strategic decisions. So this one is kind of real world. The second is really cool. Also, the first time I think we've done this, it's in collaboration with the arts department here at Berkeley. And it's creating, Capstone projects will be creating the technology platforms for the digital arts in the future. So a team will be made up of engineers and art students, okay? And again, you can see in the fall, very similar learning to the autonomous driving course, but it's applied very differently in the spring, which I think should be a lot of fun. IEOR is also looking at 4 other what they call tracks, and there's more information as you'll get if you're in the breakout session or online with some materials I'll talk to you about. In supply chain, how you use information technology for finance, making financial decisions, energy grid optimization, and machine learning and data science, particularly applied to healthcare. Next is nuclear engineering. There, the fall course is actually an existing course they have, which is really good, which is this risk-informed design for advanced nuclear systems, which is intriguing because it not only takes the typical technical look at nuclear design, but also brings in the regulatory, the business, and the political issues that are around nuclear energy around the world. Then in the spring, they're going to break up into multiple teams working on a variety of different projects that are all faculty-led. So again, it helps give you that first fall learning around what does it take to be a successful engineer in this field. In mechanical engineering, here there's several faculty members that are going to be involved in this. The fall is all about learning the foundational tools that are necessary in mechanical engineering because it's a field that's changed dramatically, and then how that applies to Capstone. And then in the fall or in the spring, you break up into your Capstone projects. And you can see that these are the 4 primary areas: robotics and controls, tech, nanotechnology, energy systems, and medical devices. But if you go on our website, you can see there's actually a few more. And then finally, another course that's really coming together very nicely is hosted by the Jacobs Institute for Design Innovation. Check them out online. They're fairly new. They've got an incredible facility with rapid prototyping tools. And what they're doing is a course all around digital fabrication. The fabrication, how we make things, is changing dramatically. And in the fall, you'll learn how to do modeling, how to actually do 3D printing, how to actually look at different fabrication methods. And it's a very hands-on kind of roll up your sleeves and learn these techniques. And then finally, the spring capstones are all about kind of creating new tools, printers, materials, and this one thing that fascinates me, which is as the world goes to more robotics, as Colin was talking about, how do we as humans interface with that? Okay, so those are the new Capstone experience courses, which we're really excited about. The second model is what we call university projects. These are the ones, if you go onto our website in past years, this was the largest group of projects. They're year-long, led by faculty, and usually working with their research groups. And again, you're largely using Berkeley technology. A lot of times you have partners working there, but it's still more technology coming from your Berkeley labs. I want to show just one example to bring this to life. This is a team that's developing oscillating wind power, and I'm going to let them talk about what they're doing.
Imagine a landscape with rolling hills, green trees, and lush pastures. Beautiful, right? But coal and natural gas are changing this landscape by causing pollution that is destroying our planet. Wind turbines are one solution to harnessing clean energy, but they are loud, they harm avian life, and they're unattractive. To address these issues, we've developed an affordable oscillating wind powered device. It operates quietly, is safe to surrounding avian life, and is aesthetically pleasing. Let's make the world a better place.
We also get to highlight what a beautiful area we live in, because you're not going to see it today. This is a video that was actually made by a team last year. Each of you in your capstone will do a video with Alex that illustrates what you're doing, and here's the team members. The reason I picked this one to highlight is actually a lot of our teams, a lot of our capstones actually live from generation to generation of students. So there's a new team this year that took over this project, and they were really interested in studying sailboats. And if you remember that first design you just looked at had a flat sail. If you know anything about sailing, you know that sails aren't flat, they're curved. And they're curved because they're airfoils. And by recognizing that, by having that insight, and then using that to redesign the mechanisms they use to create energy as that sail goes from side to side, they went from last year's output was 1 milliwatt per half square meter. The device the team's working on this year is 1 watt. They improved output by 1,000-fold. That's an idea that didn't come from a Berkeley professor. That's an idea that came from that team simply because they looked at, what is our device really doing? What's really critical here? So I love that example because it shows you the power you can have, okay, to really drive this. Once you get, and their prototype's not very big, right? Once you start to get 1 watt out of that, now imagine scaling it up. You get something, they're at the point where this could start to become practical. The third type of project we call partner projects. Now these are a little different in that the project is led by one of our industrial partners, okay? And you'll use their technology, you'll use their equipment. You'll still have a Berkeley faculty person assigned as a liaison, but they and their group are not leading it. Your industrial partner is. And you can see our partners over the years have come from a variety of different companies. So we're quite proud of folks we work with. Some of these guys, if they're not leading partnership projects, are actually partners on university projects as well. Needless to say, the university labs are well connected to industry. So this is kind of the types of projects. The other thing we're quite proud of is we've had now 3 startups, successful startups, come out of Capstone projects. It's where a team really wanted to stay together. They were getting good success, and they liked what they were doing. We have one team this year who's going to try to do it. They're we're now in the process of trying to figure out how to get funding. And once again, being in the Bay Area is one of the hottest incubator areas in the world. So this is a great place for them to be. So we're hoping they'll end up taking their technology forward. And the question for you is, are you next? How many of you would like to start a business? Quite a few. Okay, good. Well, you're at the right place. This is an incredible area. I went through a lot really fast because I want to get to Q&As. There's a lot more information available. For project profiles, go onto our website. You'll see several projects profiled. There's a YouTube channel which shows those videos like I just showed you for all of our projects. There's also, in your Admit website, there's also this list of the current projects, these 83 projects that we've got going right now, so you can see the kinds of things students are working on, and then a tentative project for next year. That's still under construction. We'll talk a little bit about the timing for the rest of the program, but basically we start now, and then between now and June, we totally flesh out these different proposals. So that's under construction. There's a selection process. Some of you asked me about that last night. It's relatively simple. It starts with you. There's a project list that we just talked about coming together between now and July 1st. When you arrive in August, that's when the fun starts. Some of you will just choose to do a Capstone experience class, and you'll talk to the professor and enroll in that. Others, and that will lead you to your Capstone project within that course. Others will go into what we call the Capstone Marketplace. That's for mostly the university and industry partnerships, where there will be fairs. You'll have an opportunity to talk to the individual professors and the people on the team. It's very similar to a job hunt, okay? You'll come up with where you want to go. You'll throw your hat in the ring. They'll interview you, and then they'll select the people that they think are the best fit for the team. That's how these projects are generated. We don't know. Those percentages are what we're estimating. The class will split out. We think about 50% of you will like the experience courses. The other 50 will be in other projects. We don't know that for sure. But basically, there's also finally a way of actually, if you don't find a good match with a university industry project, there's a way of actually going back into the Capstone course. So the one slight nuance that you'll probably talk about in your breakout is electrical engineering, computer science actually does this similar process in many ways, but over the summer, so that you'll arrive with a good knowledge of what your capstone is going to be. Here we are. There's this tentative project list. As I said, by July, we'll have proposals. You will get, late July, a survey where we're just trying to get a sense of what you're interested in so we know how to best set up the program. You will arrive at boot camp. There's these info sessions I talked about, that selection process, and then generally like the first or second week of September, you're working on these projects. So it's pretty fast, particularly once you get into the boot camp thing. It moves pretty quickly. Now I wanted to switch over to Q&A. There's a few that we know people are interested in, so I'm just going to cover those. How many students are on a capstone team? They range from 2 to 6. Average is probably 3 to 4, kind of in that range. But it depends on the actual project. Can I work on a capstone by myself? The answer to that is maybe, depending on how you look at it. Capstones are all about teams, so we want you working on a team. There are about 8 projects that are one-on-ones. So the MEng, the Masters of Engineering grad student, will be working with a research group inside a professor's group. So you won't be on a team with other MEng people, but you will be on a team that professor has in their research group. And some of you might be interested in that. And again, I said it's about 10% of the total. Can I use my own idea for a capstone? Only if you're very influential. If you look at the capstone experience, it is based on having faculty and other people interested in your idea. It's not just you going off and working on your own. There are cases where people do have ideas and they approach faculty and it gets their capstone going. And some of these capstone experience courses are building in a process where if you do have an idea that's relevant to the experience, then it can become a seed for a capstone. So the answer is maybe, but you have to own it. You have to drive it. Will I get the project I want? Once again, perhaps. If you are interested in the capstone experiences I talked about, those are being built so we can scale them. They could have 3 teams, 4 teams, 5 teams, and they'll just have each team will work on a different part of that big problem. That's pretty scalable. If you're looking at one of the university industry partnerships, that is probably one team, and those folks are going to pick the top 4 or 5 people. So if that's what you're looking for, you may or may not get it. The only point I make here is if you think about the purpose of Capstone, it's to teach you those things we covered in the principles. It really, although you want to be working on a project you care about, it really doesn't make that much difference. Can students work on projects outside their major? In most cases, absolutely. And in fact, we love it, we encourage it. The only slight constraint on that is some of the projects are very technical, and you need a certain level of background knowledge. And you wouldn't want to necessarily work on a project like that because you wouldn't be prepared for it. How does the Capstone Experience class, which is new, differ from university industrial programs? They all meet the same principles. They all get you to the same place. The main difference is the experience model takes time in the fall semester to build your knowledge in the relevant areas for the spring, and then that's really valuable. The trade-off, of course, is your capstone is more of a 1 semester versus the others, which is a full year. And there you're expected and not expected. You have to do all the learning that you're doing in the context of the project. So they both kind of meet all the same principles. They both will get you to the same place. It's just a different format. And with that, I'm going to open it up to other questions. Yes?
Could you just clarify with your last point, does the Capstone Experience have lectures for the first semester?
Their classes, they tend not to, as Coleman talked about, they tend not to be lectures as much as mini projects. There will be some, hey, here's material you have to learn. So there will be some lecturing. It'll be somewhat of a class. But it tries to be these classes try to be as much project-based as they can. So where in, say, the spring semester, you're going to have one capstone for the entire semester. Here you may do a project for 2 weeks to work on a certain design principle, so you can learn that design principle. And then you may do a different project for a week to do something like that. So it tries to be much more hands-on. We don't, as you heard several of the speakers, we're not strong advocates of the talking head approach to education. You learn by doing. You don't learn by sitting and just listening. But great question. Okay, one of you,
I have two questions right here. So will the team, the first one is will the Capstone project teams will be combined with like multiple like students from multiple backgrounds, like from multiple different majors? And another question is do we have the mentor from company or Berkeley or actually both, and are they familiar with the idea and the context of the Capstone projects as well?
Yes, great questions. In terms of the mix, it depends a little bit on the area. So for example, mechanical engineering, IEOR, nuclear, or actually civil, and are very mixed, okay, because engineers in those three departments can kind of, in bioengineering, similar, can go across a lot of different areas. Some teams like EECS, for example, where EECS projects do tend to be a little more technical. A lot of people that are from other engineering fields just don't have the background, so those teams tend to be a little more focused on EECS people. I think the same is probably true for nuclear engineering. If you're on a nuclear team, there's a certain body of knowledge that you have to have that if you're in BioE, you probably don't have. So it's a little bit of a mix. In the second one, mentoring, yes, every team has a mentor. It can vary depending on the circumstances. Sometimes it's actually the faculty person, the faculty advisor. Other times it's actually a postdoc or a PhD grad student who's 4 or 5 years into their program who will actually work with the team as a mentor. Both models work, but it's important for you because that Capstone project goes pretty fast. It's important for you to have that sort of mentoring. That get your questions? Okay. Next.
Yeah, so is there like a certain industry or theme that you tend to see with more successful projects, or that you tend to see projects be more successful in?
No, I think if you look at the successful projects, they really cut across all of the different fields. So I wouldn't make a decision based on that. I'd make a decision based on what you really love doing and where you think you'll get the best growth. Yes.
Could you explain to me the process if you wanted to use your own idea for a capstone project?
Actually, you own it. So basically, if you've got what you think is a great idea, you have incredibly diverse faculty here. You should start talking with them, and you can do that as soon as you accept the program, saying, hey, I'm a new MIN student coming in. I'd be interested in doing something around this. Copy me on it. Send it to the professor and say, hey, would you be interested in doing this? Okay? And then that'll start the ball. And you may find that, in fact, the professor says, that's really cool. Okay, I'd love to do that. I'll sponsor that program. And then we would turn that into a project. Within the course approach, the experience courses, then there will be mechanisms during that fall semester as the group starts to pick their projects for you to essentially influence your classmates and those advisors to say, hey, I got this idea that's really relevant to this VR AR class, for example. I'd like us to turn that into a capstone. So that'll be a simpler process for you. But other than that, I would do want to emphasize you own it.
Hello. Given the short time frame, has there been any incomplete capstone projects?
Yeah, but not many. Most are really careful at configuring their deliverables, their project deliverables. You can get an incomplete, but I would say, and Joy, keep me honest on this, this has probably happened maybe 2 or 3 times over our 6-year history. So it's very rare. We don't anticipate any this year. So it's all about making sure there's good communication and clarity of expectations.
Hey,
Yes.
so you mentioned the marketplace for choosing your project. Does that similar process go for choosing your group, or do they do that just by interest? You do that by complementary skills, or how do they work?
I'm sorry, would you repeat that? I missed
How
it.
does choosing your group go? Like, is that purely based on interests, or does that based on complementary skills?
Absolutely. You mean your teammates? Yeah, there's a whole another process running under the surface. In theory, we don't choose that. Okay, we being the university. Okay, it can either sometimes happen randomly, which 4 or 5 people come together, they want to work on that project, and the advisor just hires them. This underground process I was talking about is actually a lot of times students will meet other students that they really want to work with, and they'll start to kind of bid for projects as a group. Okay, and that times you'll often have, students will kind of form their own teams, but mostly it is through that job hiring process. And the reason that's really important is that when you go out and get your job, you don't pick your team, right? Your team is your team, and you have to learn to work with those folks. So we actually like and encourage that. Next question.
Yeah, so this may be a little bit difficult to answer, but how does the career trajectory between the MEng students differ from the Master of Science students here at Berkeley?
Julie will talk about that.
Okay, I've been given the heads up down here that Julie's actually talking about that in the afternoon. So rather than me getting into here, let's just defer it to her.
I have a few questions. When you're ranking the capstones that you want to choose, does it say like off the bat how many students they'll take or how big the team is? And I'm also wondering, for current students or alumni, what is like the biggest thing they got out of the capstone? Like, how has it helped them? What was their favorite part? And have you seen any projects that have gone on past the MEng 1 year, like either they've gotten funding or they've continued the project?
Yeah, okay, I'll take the last one first. There were those projects that I threw up there. Those are projects that did go on, and they're the ones that successfully got funded, and now they're startup businesses. So yes, that does happen. And it's generally, to quantify it, it's generally about 1 a year. It's kind of our average. Maybe in some years there have been 2, but it's not common. Generally, people want to do their capstone and they go off in their job, in their career. But you're certainly, if you want to do it, you're in the best places you can be, because there's a lot of funding for student startups here at Berkeley. In terms of, what was your first question again? How many students per project? Yeah, if it's one of these projects I highlighted, the capstone experience, that can be 25 to 40 will be in there, broken into teams of about 4 to 5. If it's an individual university project, assume that it'll be about 5 people, max. However, there's always a however, right? Some projects have been so successful or so popular that the professor has divided a project into, say, 2 very similar pieces, so they can have 10 or 12 students working in their area. So the faculty is incredibly supportive of that when they see that, wow, whatever project I'm proposing is really getting a lot of attention. And you had another question that was in there? The best thing coming out of it. The ability, 2 things. One, which people know during the program, and then 2, they only understand later. The first is you live it. It's not sitting here talking about innovation and being on a team and doing things. You're living it, okay? And the benefit is when you go out and get your job, you're going to do that. That's what your life is. So it gives you the ability to do those same things in a very supportive, nurturing environment like Berkeley. The other thing, and I only hear this from the alumni when we get together, because we have a very active alumni group, is your networking. We have people that are, classes of 5 years ago that still, instant message their Capstone team members. Because it's a very intense experience, okay, you will form bonds with those teammates, okay, and those bonds last. So as you think about your future career, it's all about building networks, and that's really valuable. You won't know that, you won't appreciate that until about 3 years from now. Other questions? Yes?
So if you're in, say, bioengineering, are you allowed to take, say, a mechanical engineering capstone experience class if you'd like to work in like medical devices or something?
The simple answer is yes. Those classes, that mechanical engineering experience class is open to all engineers. Back there?
You had the slide with 3 silos, the technical side, and then the demand side, and then the wedding in the middle.
Right.
Is it more that teams will be assigned to a demand silo since the degree is like 60% technical? Or is it that an individual within a team might live in that silo? Could you speak a little bit more about that?
Yeah, it's a great question because it's a little bit of both. And it varies a lot by capstones. Some capstone projects actually go across the entire range. And they do consumer testing, right? They talk with consumers. And then they build prototypes because they've got technology. So they actually touch each of those 3 areas. Other teams will do what you just talked about, which is they'll touch all of those, but they'll say, hey, you know, we got to get a lot done. There's 5 of us. You're going to work on the consumer piece. You're going to really work on, and you 2 guys are going to work on prototyping, et cetera. So they do kind of carve it up, and that's actually a really good thing. And then, you know, basically, in terms of some projects, and I think Coleman talked a little bit about this when he talked about some of our projects are like research groups. There are some projects that are really just doing deep dives and developing new technology. And they have visibility to the solution and the consumer need because it's important, even if you're working on technology, to know where it's going. But they'll spend, you know, 95% of their time actually doing research and development in around a specific technology. Did I get your questions? Okay. Down here. Oh, where are we? Where's the mic? There we are.
Have there ever been multi-tier projects where you might have committees and a larger group of people?
Yeah, it's in the Capstone experience. That's going to be more common because you're going to have a structure around it, and you'll have multiple groups working on it. Oh, wait a second. Maybe are you talking about hierarchical projects? Say more.
You might have like multiple committees, and each one works on some part of the project.
Yeah. Okay. Like in that Internet of Things project I talked about. That's exactly how that's going to work. In most of the university projects, they do tend to be a little more independent. Okay. So I'm working on the wind turbine, for example. And I'm interacting with just my group. And interestingly enough, particularly for projects that have generations, those guys will actually talk to their predecessors. And they kind of reach out to those folks, the people who were working on that similar project last year. But think of those as being a little more independent. Last question.
I know a lot of innovation requires like a change of an idea or like adaptation as we continue to learn more about what we're trying to do. So I'm wondering if there's like room for that flexibility in the Capstone projects or if they're already fairly set in the direction that they're headed.
Yes. In fact, it's interesting. When you look at the problem that you're seeing right now, when you look at that list, it will morph multiple times. And it morphs because the students have better ideas as they get into it. So there's tremendous flexibility. You own it, okay? Some teams actually end up migrating and working on a different sort of thing, okay? So that's kind of an extreme case. But no, you own that project. It's your project. Where you go is limited only by your creativity. And I think that's the last thing. I thank you all. I will be around all day if you have any additional questions. A lot of your questions you can also talk in the ask in the breakouts. And with that, I give it back to Beth.
Wonderful. Thank you, Wayne.